Welcome to Mr. Chalk's Revision Tips. In this video, we will look at
alkanes, the properties of alkanes, and crude oil. So, hydrocarbons are compounds that only contain hydrogen and carbon atoms. So, crude oil is a finite resource which is found in the Earth's crust. It is the remains of organisms that lived and died millions of years ago, mainly plankton which was buried in the mud. So, crude oil is a complex mixture of hydrocarbons. So, the carbon atoms in these molecules are joined together by chains or in chains or rings. So, we can see there, if it has one carbon atom, it is called methane. Two carbon atoms, it would be ethane. Three would be protein, and four would be butane. So, crude oil is an important source of fuels such as petrol, diesel, kerosene, and is the feedstock for the petrochemical industry. So a feedstock is a raw material which provides the reactant for a industrial reaction to take place, and they can also be used, or substances found in crude oil can be used for solvents, lubricants, or detergents. So oxygen is needed to burn fuels. So name the source of the oxygen needed to burn fuels. That would always be from the air. So what two elements are hydrocarbons made of? That would be hydrogen and carbon. And what do we need crude oil to make it useful? So to make crude oil useful, it needs to be separated out using fractional distillation. Alkanes are saturated hydrocarbons, so this means that their carbon atoms are joined together to each other by single bonds, making them quite unreactive, apart from their reaction with air, which occurs during burning. So, if we actually look at the lengths of the alkanes, so as the length of the carbon chains get longer, its boiling point increases, making it become more viscous. So the table below gives information about hydrocarbons. So the hydrocarbons are successive members of a homogeneous series. So if we look at the table, if we look at what the formula would be for B, it's going to be something that follows the pattern. So it would be H4, C4, H12. So describe the relationship between temperature of a liquid hydrocarbon and the viscosity of the liquid. So the higher the temperature, the lower the viscosity. And if we're looking at describing how the ability of a hydrocarbon to burn with air changes with length, so the longer the hydrocarbon chain, the less easily it will burn. So if we go and look at this graph, that kind of shows how the boiling point of the hydrocarbon changes with length. So something like methane with only one carbon would have a very low boiling point. However, once you get up to octane that has 8 carbons, then you're looking at a relatively high boiling point in comparison.
Thanks for watching.